now we're going for the new hotness, the new attacks on vectors, on new attack vectors for mobile core networks with Doctor. That's important.
Well,
we are in Vienna, so the title is very important.
Yeah.
So please give a very warm applause to Dr. Silke Holtmans.
Thanks a lot. Yeah, in Austria I decided to go with the title, sort of, yeah. So not to be sort of mistaken for the secretary, sort of has happened more than once. Never mind. Today I talk about new attack vectors for mobile core network, so not about the air interface, but really what's happening in the back end. And I'm from industrial research. Nokia Bell Labs is the research branch of the Nokia networks, so not the phone side. The phone side went off to Microsoft and died there. So I'm part of the research branch that's looking at the really sort of what's happening in the network and how we can help those networks. There's some pros and cons to be in the sort of industrial research side. On the cons is if I come with something, hey, I have found this pretty cool attack, and I cannot say like the universities, the industry has to fix that, because the industry comes back and say, fix it. So I have done the problem. So I need also to come up with solutions and how to fixing, how to improve the situation. On the good side, I also sort of see impact. So when I come up with a new countermeasure or when I come up with a security feature, it really goes into products. Everybody here in the room has some security piece in their phone I designed. So everybody here. If you have 3G, it's in there. So that's also very nice from a researcher's perspective, that the stuff goes really real, it doesn't stay theoretical. So, and also customers talk to me, they trust me, they tell me their problems, they tell me how they really do things in the network, how much money things cost, how feasible or not feasible is something. So I cannot come up with countermeasures which are so exotic and expensive that they just say, forget it. So that's basically industrial research. So just a briefer, we already got a snapshot in the previous talk. You're here somewhere in this building, very nice, and you're connected to 3 Austria, T-Mobile or A1. The participants here are from, let's say they are from Asia, from China, then they have a China mobile subscription, from India, then they have Airtel, from Megaphone if they happen to be from Russia, or Telenor if they're from Kazakhstan or Pakistan. I'm from Finland. I have a Lisa subscription, or my friends have from DNA and Telia. These are independent companies. When you touch down here with your airplane, you switch on your phone and it works. The network here has never seen you before. They don't know anything about it. Still, it works. And in the difference to let's say, credit card companies, there is not a global entity organizing these things. These are all different legal entities which compete even with each other sometimes. And they are sometimes in countries which are hostile towards each other. Pakistan and India, they are not best friends, for sure. So that's done by this interconnection network. It's called IPX network. It's a sort of hidden private internet. And basically the lines there are just roughly where the big cables are going. There's a big hub in Frankfurt, for example, and on the French coast there's a big hub, then in Wales, and on the East Coast and on the West Coast in the US there are big hubs, and in Rio de Janeiro is another big hub. So these are the connections. All your communication runs through that. So, and you can think about it as a sort of bit like a corporate network, a sort of old-time internet style, a bit like that. So if you think about it. And let's go back to really understand the security, you have to go back sort of where the stuff is coming from. So, but let's start first. I switch on my phone here. It connects to an antenna, maybe on the church over there, and then it goes to the core network, to the operator I connect here. So the core network are really the servers, the backend servers that are sitting somewhere in the underground. And then it most likely goes via some carrier or IPX hub, in this case most likely in Frankfurt, and then the messages go to Finland. What happens then when I leave the airplane? Basically, this message flow happens, and they ask, does this person is allowed to roam? Does she have money? Does she have prepaid or postpaid? Does she have a data contract or not? So basically information about me, about my credentials, about what kind of services I'm allowed to use and so on, are running that way. So that's why it takes so long when you enter a country, why it takes a minute or two till you really get service, because these kind of things happen then in the background. So because if you just have a local subscription, prepaid, local, like some kids subscription, then you don't get service. So to understand security, we need to go back to the start of roaming. So there were 37 years ago, there were 4 operators, most of them state-owned, Finland, Sweden, Denmark, and Norway. And they decided, if you ever looked at the map, they're pretty big countries, and they have long borders with each other, for example, at least sort of Norway and Sweden, and it's pretty empty, so they wanted that roaming works, and if you come across the border, still you can get service. And it worked. Marvelous success. And that's how it looks now. So the plans have grown a bit, the services have grown a bit. I mean, considering the first calls, that was 2 and 2.5G, that was still sort of somewhat okay-ish. And then there came the IP version, that was called then Cictron. And then we moved forward to 3G and 4G. And now we have 5G sort of on the horizon. So for the radio access network, 5G is in the rolling out phase. For the core network, it was specified finally in September. So it's on the road. So it's an organically grown structure. So you see still all kinds of networks out there. If you, let's say, drive in a less populated area, you might have only GSM connectivity. If you're sort of a bit more sort of city area, you'll most likely have 3G, 4G. So, just brief, 37 years ago, few state-owned operators. And it was built on trust. Those guys, I'm pretty sure they went to sauna together and were talking there how it works and so on. I'm absolutely sure. They had similar understanding how things should work, and they were state-owned, and they didn't bother about security. Why should they? It was a closed system. In particular, they had no source authentication, which is one of the main pain points nowadays, and which actually enables many of those attacks that we saw in the previous talk on SS7. Nowadays, we have something like 2,000 partners in that network, instead of 4. And also the whole thing was constantly extended and extended. I mean, every day you see new features for your mobile phones and wider data and more bandwidth, less latency and so on. And nowadays we move on the IPX, that's the interface between the operator networks, also to 3G and 4G, and that's the diameter-based communication. And somewhere at the horizon, we see 5G core networks popping up. So they are specified by 3GPP, and they are already specified, but they are not yet sort of out in the market. And let's come back to the assumption that this is a closed and private network. We saw on the previous day the issue about potential backdoors, but I think they are much more, so we saw much different attack angles, actually. On the left side, you see there from 3 in Ireland, that's the wholesale interconnect business. What is that? If I want to become an operator, let's say IoT, I become an IoT operator for industrial plants. I could go to the local operator here and say, I want to have access to your network, and I want to rent the service from you. And the EU law mandates actually that those guys have to give me the access. The idea of the European Union was to encourage competition, so the operators could not say, we don't give it to you, and by that keep the business. So it's an anti-competition thing, so which is good. So, but on the other hand, how does the local operator, which rents out the access, really knows that these are good guys renting the access? They don't know. So there it comes to the thing sort of that you need to monitor your tenants. Their left-hand bit sort of, that's a service from the darknet, where you can run for a specific time the API or SMS interception or things like that. So that's just business. On the bottom you see a GGSN. Here you can see it a bit. A GGSN is a core network node, and it actually has no point in being on the internet. I don't know why it's on the internet, and you can find it on Shodan. I think it has finally been taken off. And then there are things here on the right-hand side. You see here from India. Somebody has put their network management protocol with telnet login. I don't know why those guys, maybe he just had to 24 hours work shift and he wanted to do it from home. I don't know why it was there, but it was there. So these things happen. Maybe it was just an accident, I don't know. On the top we see from the Shodan leaks that as a map of mobile networks where the NSA had access to or some access. It's from 2014, so it's probably no longer up to date. But anyway, so back to the assumption it's probably no longer a closed and private network. There are entities there that, or people can get into it if they want to spend money. So they can rent a service from a darknet, they can kick in the door. You have to remember that operators were formerly state-owned, many of them, and they have very close ties with, sometimes with the government. So, and they're also regulated, so they won't need their license. Their license means money and business for them, and if the government says, oh, you don't give us access, do you want to have a license next year? What should they do? There's a bit of trouble in there. They might be hacked via the internet. Accidents do happen, misconfigurations. People can become an operator, bribing of employee, classical, and of course social engineering. There have been tries of social engineering on that one. So even what we would say consider friends and partners, they are sort of, let's put a question mark there. Belgacom was, that's now Proximus, a Belgian operator, was hacked in 2013. And then there were questions asked, and the Belgian government asked then the UK government, hey, what's going on there? And they just say, we don't answer. So you don't need even to look very far from where things might happen. So, which is sort of somewhat varying, at least in my opinion. Also, this is from the internet, and this is a GTP scanner. GTP is the data protocol. Everybody is using that when you set up a data connection with your phone, you use GTP protocol. And this guy is a scanner which scans through the internet and crawls there and is looking for open GTP ports. GTP is normally not used in the internet. So why are they looking for it? So they are really active participants which look for open GTP ports. This was basically now we will talk about protocols and its evolution, because not all protocols work and not all attacks work for each protocol. So first on the attacker side, you have to think like an attacker for sometimes. And for an attacker, why do they do that? They see this as information acquisition possibility, let's say for the military, for targeting, let's say terrorists or things like that, or other information sources. So if they have 2G, 3G, or 4G, I don't think they really care. I think for them it's just a technology evolution. Like for us, okay, then a new tool, then a new protocol. Who cares? You just adapt to it. It's a new thingy you have to do. And for them it's the same. So the attackers evolve the same way as we do. So they go with the technology. So when we see attacks for SS7 and 2G and 2.5G, we will also see them maybe slightly different way, at least the tries in 3G, 4G, and 5G. Already mentioned some of them. That's for SS7. SS7 is still the most commonly used protocol for IPX, meaning if you call from here, let's say from from 3 to, let's say, T-Mobile, then this IPX will be used, or sort of. So for SS7, we know location tracking, eavesdropping, fraud, denial of service, credential theft, data session hijacking, unblocking of stolen phone is depending on the vendor, SMS interception was just discussed before, and then, yeah, well, that's basically it. So SMS and what goes along with it. Big disclaimer, only if no protection is deployed. Networks are very, very different. Not all networks are equal. Actually, in Austria, I think they are nowadays quite good quality. I think there was a big wake-up call when this banking transfer sort of happened. This incident happened a bit more than a year ago, but they discovered it actually quite fast. I know the guys who discovered it. So a lot of things can be done, but some people don't want to invest money, they don't have security experts or whatever. So countermeasures, what can be done for SS7 and Cictron? Cictron is the IP version of the SS7 stack. There are standards. The GSMA Association, that's the Association of Operators, where they talk about how to do roaming, basically the technical part. They have documents which describe how to monitor, how to protect, how to build a firewall, and things like that. And they actually have even a vulnerability program nowadays, because they see things like, you remember this morning, this keynote talk in the morning where this animal was with the ape and the elephant, because we also get now IT attacks, so they have also a CVE program. So, well, we accept that we are now IT, more or less moving IT-ish, and then we have also CVE program. Regulators. The Nordic countries have a regulation on SS7, the same for EU ENISA. That was published in March, and the FCC US was also published on the 15th of March. They're all recommendations, but Nordic countries, it works. EU ENISA, that has to be translated into local legislation, and I think there will be a sort of quite strong push to do that. US FCC, I think it's just a recommendation. So that's because the current political climate in US is not really inclined towards regulating the industry very strongly. So might be changing, who knows, but that's the situation now. Products, actually there are now firewalls that actually understand telco, because telco had their own language, meaning message application part. And also there are security functionalities now in the nodes itself, sort of to at least kick out stuff that might go through. And also there are services nowadays. I mean, the previous speaker was basically doing pen testing, so there are now these services. They have not been there 10 years ago. So, and also some sort of public community, very small, because it's a very weird topic actually. So I just heard that there in Prague was a sort of community for this kind of thing. So there are things evolving, but it's a dinosaur and it moves not that fast. So that's technology, 3G and 4G, basically what everybody of us is using. The functionality is similar to SS7, but the protocols are different. When in 2014 the SS7 thing basically blew up, we are just a few people. It's just a fact, we are not that many. So the people that really protect the mobile phone networks, we are not that many. So we were thinking, okay, diameter, we need to do also something there, but SS7 was sort of burning in front of our face. So we decided, okay, let's fix SS7 or do something about that as much as we can, and then we try to fix 3G and 4G. That was what we did, priority on SS7, and then we pretty fast moved to diameter and 4G. And then we also, basically, I programmed attacks just to see if they work in diameter, and then also the countermeasures. But still, there's not a global trust authority in the IPX, and I don't think there will ever be, which makes life a bit harder. So there's not a global PKI for IPX. This will never happen. Would be nice, but will never happen. Also, what's noteworthy, that the attacks are more operator-specific, meaning that they really depend on configuration, which software version, what kind of nodes, and so on. And up to now, we have found the following attacks: location tracking, that was in 2015, I think I published that one. Then we had fraud. I will present the fraud attack today here also, that you can see how it works. Then data interception and denial of server of subscriber. Denial of server of subscriber is always the most easiest attack, actually, by far. Because just screwing up something and the user's disconnected is so not that difficult. Once you are in the IPX network, that's always the big assumption. How do the attacks work? I will give an example of a charging attack. Charging is basically billing. So this charging is the thing that happens in the network before you get your bill. So don't worry, it's not too bad. So that's the test network that we used. So in Nokia, we have a test network. And the purpose of this test network is to copy basically an operator network into our own environment. And then we use that for rolling out software. Because our customers are very, very annoyed with us when we roll out software patches and screw up their network, because then they don't make money. And they don't like that. So we have this test network, and those guys actually in our test network, they allowed me to use their network for security testing. So they're very nice people. So this is part of our test network. So we have there basically the terminal, that's the phone here, the UE. Then we have the base station, that's the eNode B in 3G and 4G. Then we have the MME, that's basically M like mobility. So meaning this guy keeps track where you are and if you are moving from A to B. Then you have the HSS, that is the big database where your location is stored, what kind of services you have, and all these kind of things. Also what phone number, identifier, and everything is stored there. Then we have the serving gateway and the packet gateway. And then we have this function we will focus actually on in this talk. It's called PCRF, awful abbreviation. I fully agree. But basically this guy keeps track what are you doing and how much money you should pay. so very important. So this you can sort of imagine. So there is the big IPX network, and you have all these operators connected to it, and they talk to each other basically to say, hey, this guy in Austria has now that many data used, so please charge it to his phone bill at home. So that's how it usually works. If they both support diameter and S9 interface. If they have the old technology still, then it runs slightly different. So this is actually how it looks like, so our emulator. I'm not going through it, so how does it actually work? If I'm now from Finland going here to Austria, so my home is in Finland, I'm visiting Austria, and I switch on the phone here, then basically the network here is asking, hey, what kind of service contract, what kind of contract does she have? Okay, does she have money, and so on. And once in a while, the home network can actually ask, hey, is this person still online? Can you please re-authenticate her? And then authentication 1 can take place. These are the two messages, basically, that we will use. So in the attack. So what we are doing, we are just misusing the existing message flows. So, and I have briefly, what is the PCC? That's something everybody of you here has. It's something policy charging control. If you would be in US, you would say that's your subscription plan. So basically it says if you have prepaid, postpaid, 4G, 3G data, what kind of, basically what it's in the advertisements usually. That's then coded into a string, and each operator has a set of strings describing these kind of things. So data type, data rates, and so on. And this PCC we need to catch first. So, and the idea of the attack is, I have a subscription from a company. So basically my company is paying everything I'm doing with the mobile phone directly by the operator, meaning I have unlimited data. So I have a very good subscription. So the PCC for my subscription is very attractive to an attacker because it's unlimited data. and unlimited service. So the attack goes like that. I steal the string that describes the good subscription, and then I update some prepaid cheap subscription with that string. So basically upgrade that cheap subscription and make it a sort of free data for a month until the thing blows up. So very useful for travelers when you go for, let's say, to a country where roaming is quite expensive, let's say US, from here to US or from here to China. Roaming would be very expensive. So as an attacker, I could then sell upgrades of subscriptions. So the attacker would actually pose also as the own home network. And again, this only works if there are no firewalls, specific firewalls in the middle. And first, just send a re-authentication request. And actually what you can do, you can set some parameters and say, please send me the quality of service rule installed attribute value pair, AVP. And that contains actually this magic string, this PCC string. And that's how it works. So this is Isha there on the bottom. She could not come today, but she basically, let's see. So basically what she's doing here is sending the messages. So, and that's Wireshark and awful quality. But I have later on a bit larger screenshot of how that works. So basically what she's showing you that here is the magic string, that if she sends this re-authentication request, that she can get these magic strings. So here's a bit of bigger. So we have the magic strings obtained here, and now we know sort of the good subscription and how to get it. So these are the charging rules, which are usually communicated. And now the trick is basically to update a cheap subscription, and there are two possibilities of doing that. And again, posing as the home network and trying to do this permanent update. And then there's very interesting that actually the answers does not need to be routed correctly. Alternative 2 would be if an attacker, if basically somebody's traveling abroad and you want to update the subscription for cheap roaming, then you also use the raw message and update this element. So, and that's how it works with the emulator. So we have here actually the terminal on the left-hand terminal side. That's the control plane of the terminal. Then we have the mobility node. We connect the terminal to the mobility node. And then the request to the HSS is running, and you see here resolution is not so optimal. So basically, here in the end, the messages are really sort of changing the PCC thing in the receiving node. So, and here's the whole thing by diameter. I think I just jump through it because the quality is not so optimal. So here's before and after. At least you can see, I think, the orange number. I think yellow was not maybe the most best color, but yeah, but what you can see here, you have here 3, 4, and you have 3, here 3, 1, which basically means this was before and this was after. Actually, what we did was more a denial of service attack, actually, because we just restricted the amount of services. But of course, you can do it vice versa. I mean, it doesn't matter which way you can do this. So it can also be easily turned into a denial of service attack. What you can do is sort of, you can, once you have these strings, you can just put them into the system and make by that an attack. So what can we do for 2G, 3G, 4G? And basically, we can monitor the network traffic, we can do penetration testing, we can do retesting. Tenant monitoring is also important. So there are a lot of virtual operator. And if an operator basically opens up their network, do they really check what those guys are doing? So it's not just opening the LPR, but really checking sort of if they stick to what they are supposed to do. Then you can mitigate. I already mentioned some standards by GSMA. There are now also special firewalls for signaling, understanding that's for diameter and SS7 and Cictron. And then there are, of course, IP firewall that's in the right-hand corner that you cannot see. And then there is SMS home routing. It's sort of okay-ish protection. It's not the silver bullet, but it's sort of okay-ish. Share experiences. Business rules, that's something interesting. How can provide business rules, security? I'll explain that to you. Because as I said, they are sort of the operators, they're independent companies, and they are sometimes from countries which even are hostile towards each other. But on the other hand, those guys are doing business with each other. And the GSMA is now considering extensions to have a liability. So if one operator screws up the other operator, they get less money. And then that makes it interesting for security, because then there might be suddenly a budget for security, because that's very often the case that there's no budget for security. But if it hurts and you make less money, then there might be suddenly money also for security. So business rules and contracts are actually a security measure, if you do it right. Also, what's important, cooperation with legislators. This stuff is extremely complex. You saw the picture with this jungle. You remember that one? And there are very few people in the world which really understand how things work. And they are not all sitting in the legislators. So it's very important that the legislators and operators and vendors work together to make the networks more secure, because a lot of things will be in future relying on that. If the network goes down, it might be sort of a critical thing nowadays, because there's so much connected stuff. And of course, you need also to have plan B, basically, when things go wrong, layered security, zone security, so if one part of the network is affected, it doesn't go into the other network, hardening, testing, and so on. 5G, work ahead. Security is a road. For those of you who don't speak Finnish, there might be a few in the audience, that means varo avanto, and that means there is ice hole swimming behind that. Since people do ski on the ice and walk on the ice, it's a very useful thing to have these signs, because you don't want to drop into the ice and die. So information is very useful, and so 5G. Security is a road in the sense that yet you need to evolve to understand things. 3G, 2G, 3G, 4G, they had each was security-wise better than the version before. So also 5G has now some very good protection against false base stations, for example, the Stingrays or Rock base station, however you want to call them. So it's much, much harder in 5G. Also, when you use your operator-provided Wi-Fi, let's say in Frankfurt Airport from T-Mobile, just to mention some example, it's also now high-quality security in 5G and works well with the rest of the network. Also, there is a new security proxy introduced in the 5G architecture, which wasn't there in 3G and 4G. And security functionalities can also be virtualized. This is very important for denial of service attacks. I mean, in the moment in a 2G or 3G network, basically you have to really put physical new servers in there. And telco servers you don't get from the next shop, so you really have. But now in the future, it will be possible to virtualize them, so you can easily sort of scale the security. And also there will be some steering possibilities for operators to provide them to their best partners. But security is more than just standards and functions. This is basically a snapshot of the security standard approved for 5G in September. This is called service-based architecture. That's how 5G networks are running. So the IT guys here in the room, they were suddenly, oh, REST API, HTTP. I've heard that before. Yeah, there we are, telcos coming to your direction. Right and left-hand side, these are two telco networks, and they talk to each other. And this SEP in the middle, that's not the DEP, that's a SEP, Security Edge Protection Proxy. And they talk to each other and basically protect the network on the left and the right side. On this strange middle line that's going there with the little bubbles on top on the bottom, these are all the core network nodes which do charging, mobility tracking, authentication, and so on. And they will talk to each other using REST API calls. And telco suddenly needs to do IT security, which becomes interesting. So, because we need to differentiate between authentication and authorization, also for telcos, and that suddenly means something very interesting. These are the classical HTTP methods. We have get, post, put, patch, and delete there. So what could go wrong? Oh, well, a lot. So if you send from one network to another, how does the receiving network know that the requested information element, like say location, makes sense? Now you need to know international operators, when they put a new service, then they don't roll out the service everywhere at the same time. What they do is they will buy one box, put it in one of their networks, and then all the partners are also using that box, just to see if the service flies. And for the beginning, it scales okay because there were very few users, but it makes a lot of business sense. You don't buy it for everybody just to have an investment that nobody cares about. So because they're not 100% sure if the service will fly. So what they do is they buy one box and they can access it. So it might make sense that the GET request is actually doable from one of those partners, but not for everybody. And there comes the trick with the authorization. So you need to think about how to code these contracts and relationship that each operator has with another operator into policies for HTTP telco communication. So you need to think really sort of who is allowed to modify what under what circumstances. Here in Austria, you might want to have that one operator can access the location of the other operator for pizza delivery, I don't know, or inside EU, sort of for emergency location or things like that. But you probably don't want, let's say, that an Asian operator can suddenly do these things. Also the charging nodes. You might want to have that, let's say, if you change suddenly your subscription because you just upload a prepaid account with a bit more money, then you want that probably that this in EU works, but you probably don't want anybody meddle from a different continent. So, and of course you don't want that somebody is deleting subscriber data. I'm really sorry about on my screen it shows a bit better, so yeah, okay, I see. So basically, who's allowed to do what? That's the big question. And this is part from the specification, sorry it's so boring. A network function is talking to your main database as an operator and is doing something. And this something has to be checked. So if it's okay, if it's allowed to do that, as said. And there are a lot of things that could go wrong. There could be fraud, location tracking, or data interception, because there are also sort of things like called packet flow description. Means your packets flow to the internet. The other thing that's sort of coming now towards telco is that there are a lot of REST API vulnerabilities known. For SS7, it's such an obscure thing. It's similar a bit to SCADA in that sense that it's sort of, there is very little known. But for REST API, everybody knows, well, maybe not everybody, but a lot of people know it. And if that's used in telco actively, then also the vulnerabilities, it doesn't take 20 years for them to pop out. They're then, oops, there they are, remote code execution, data stealing and authorization fail, denial of service, and fraud and data theft. So it's not only that this stuff will be out there, but they will also be known very fast. And this is here from Shodan, for the people who didn't know it, sort of, I suppose most of you people know it. And there's integration with tools like Metasploit. So meaning that you immediately can sort of use your Metasploit and here we go. It's that's a very nice tool, I like it. It makes life so much easier for an attacker. But it's not only that the vulnerabilities will be found, they will also be potentially be exploited. So we have to pay attention to a little configuration details. This is an Indonesian operator. And for the people who are familiar with REST API, There's a little star here, access control allow origin. Everybody who knows, yeah, yeah. Telco meets IT, welcome. And they even say what version they're using, very nice. Well, I was not the only one found that, so it supports putting of information and deletion. And they say which software version, REST API, everything you would need. Well, that's 2 weeks later. Basically, that means that the command and control traffic was running on it. Yeah, well. So little things, little dash, just to make things a bit more convenient for, here we go. So it's very easy to do things wrong. Well, going back is not really an option. So we have to pay attention and move very carefully forward. So to-do list for 5G. Some stuff is on the vendor, some stuff is on the regulators, some stuff is on the operator. Security testing, that falls on our table. We have to do sort of this software composition security analysis, not just download every code from the internet and put it into our code. Port scanning, vulnerability scans, robustness testing, so throw the stuff at it. Preparedness, that's more an operator yard, meaning sort of if something goes wrong, know how to put backups, network segmentation, patching plans, and things like that. Deployment operation, that's something we also cannot do because we don't know who has contracts with whom about roaming, and we don't know sort of each roaming contract and how they look like. So that only knows the operator. We cannot do it from them. We can help them setting up the stuff. And of course, they need to do what I would call clean IT housekeeping. So meaning internal and external DNS separation of roamers and own ports and interfaces, these little things. And then we have also something I would call validation and life cycle. So basically pen testing, see if things are really secure as you think. Algorithm retirement, a pain, yeah, a pain. Getting old algorithms out of the network. I mean, also the internet is still running BGP, so it's not much better in telco. Getting rid of old stuff is difficult. And also when things change, you need a lot of procedures. So, and this is also somewhat interesting for legislators, what they can legislate or not, but it requires cooperation of all entities. So it's not just something sort of where you can say, hey, vendors, deliver me, or hey, operators, do this. It's not working like that. We got some money for this research, so thanks to those guys. And let's go swimming in 5G, and are there questions? That's an ice hole.
Thank you very much, Silke. We do have a few minutes for Q&A, so if you have a question, raise your hand. I will come with the mic. Silke is very helpful. Ask almost any question, I think.
I cannot answer about competitor products. That's a no-go.
So, questions? Yes?
From your point of view, do you see new attack vectors when a device is using eSIM compared to a normal SIM?
The eSIM is a slightly different topic. There is a PKI embedded into a non-removable USSD card or SIM card, and then the subscription profile is downloaded. Basically, the subscription profile is the application that's the authentication application, I would call it, what you usually have on your removable card that's then downloaded. And of course, if the it's money, the risk is more on the operator side, I would say. I don't think the risk is basically on the user side. So. But they have actually certification programs, so not everybody can send anything to the embedded USSD. That is, if you go to the GSMA website and search for remote provisioning, then you find the exact which companies are allowed to do that and so on. And they are pretty tough on it, as said, because the risk actually doesn't lie in that case with the user, more with the operator, and they know it. So.
Wouldn't it be better to just dismiss all this wireless communication stuff and fiber all the stuff with fiber?
Well, that would mean that you don't have Facebook here, except if you can sort of, I don't think I mean, there's already a lack of normal cables, electricity cables.
It would be great if there's no Facebook on the phones of the people.
No, seriously. I mean, people don't want to go back, and I don't want to go back. I mean, it's just so convenient, and that's where we go. So, connecting everything, every washing machine, every toaster's connected. I'm not sure sort of you need to connect the toaster, but that's how it goes. So, and let's try our best to secure it as much as possible.
So you want fiber to the chair? Yeah. Further questions? One more? Anyone? Yes.
Hi. Regarding the REST API calls,
Yeah.
would you see something similar to the PSD2 regulation, which kind of dictates protocols in between, on the financial sector side, being applied to telecoms?
The EU ENISA is thinking about 5G. So if you go to their report, then you see that they're also sort of concerned about 5G. But I think they also talk directly to us and also to the operators, because a lot of stuff is actually on the implementation side. So, and usually legislations don't mandate implementation solutions, which is probably okay, because the legal text, it stays in the air for quite a long time, and it probably would need to be updated constantly. So they probably come up then with something like protection state of the art or something. But I expect that there will be some pressure on the operators and also on us on how to do things. So how they will phrase that, I don't know, but probably technology independent, I would assume.
So, just a general warning, the lakes in Vienna have not frozen over, so this is not possible.
I went swimming there.
Otherwise, I would say, please give another very warm round of applause to Silke. Thank you very much.